Welcome everyone to the latest installment from Garris Math. Today's lesson is all about geometric means. In today's lesson, you'll learn how to find the missing lengths of right triangles using the geometric means. Now, let's take a look at the picture drawn above. In the picture, I have two right triangles. I've got a larger right triangle, and the altitude of that larger right triangle creates another smaller right triangle. The geometric means occur when I have the shared side of two right triangles, as shown here in X. So, today we're going to look at how to set up equations to find these missing lengths. Watch carefully as I set up each equation to find our variables x, y, and z. To find x, I will set up the equation the square root of 9 times 4. You can see here that the altitude x splits the hypotenuse of the large triangle into two sections, one with length 9, the other with length 4. Now I'll multiply 9 times 4 and get 36, so x equals 6. All right, let's turn our attention now to y. When setting up the equation for y, I will look at the short side, or the side that's connected to y, and the long side, the hypotenuse of the large triangle. So the equation that I'll set up for y is 4 times 13. And again, the reason I have 13 is because that's the length of the hypotenuse of the large right triangle. So I do 4 times 13 and get 52. I then take the square root of 52 to get my answer, which is about 7.2. Last, to find z, I'm going to use largely the same logic I did for y, except for now, I'll be using the side attached to z, which is 9. This will be the square root of 9 times the whole hypotenuse, 13. The square root of 9 times 13, 117. And now the square root of 117 is about 10.8. I have now successfully found all of my missing length. Let's look at another example. In this second example, my variables are in slightly different locations. I need to find x, y, and z. Let's try to find x first. All right, to find x, I'm going to use the fact that I know one side of my larger right triangle. So watch this. I'm going to say that 6 is equal to x, which is the short side connected to 6, times 10, which is the length of the whole hypotenuse. And I'll take the square root of that. Now, to solve for x, I need to square both sides. So 36 equals 10x, and to solve for x, I'll divide both sides by 10. So x in this case will be 3.6. Now, to find z, I can simply subtract 10 minus 3.6. And I get 6.4. Lastly, to find y, I can again set up my equation. Y equals the square root of the part connected to y, 6.4, times 10. Y is now equal to the square root of 64, and we all know the square root of 64 is equal to 8. Woohoo! We found all of my variables. All right, one last example. Again, my variables are in different locations, but I'm still going to set up the same type of equation. Here, to find x, I'm going to use the fact that I know the altitude. Remember, the altitude splits the large hypotenuse into two pieces. I can find this altitude by multiplying the two pieces and taking the square root. Since I know that 8 is the altitude, I'm going to say 8 equals now the square root of 4 times x. Just like in the last problem, I need to square both sides, and I get 64 is equal to 4x. I will then divide both sides by 4 to get my answer. Doing 64 divided by 4, we get 16. So x down here is 16. All right, now I'll find y. To set up my equation to find y, I'm going to say y equals the square root of 16, the piece that's attached to it, times the whole hypotenuse, which is 20. So y equals the square root of 320, and the square root of 320 is about 17.9. All right, to find z, I will set up my equation. Z equals the part that's attached here, that's 4, times the whole hypotenuse, which is 20. So z equals the square root of 4 times 20. Z equals the square root of 80. And now to calculate the square root of 80, we get about 8.9. All right, folks, now it's your turn. I want you to turn in your packets to 13.3a. And I want you to try questions 4 and 5. For each question, make sure you label your picture and then find all of the missing links. When you're ready, check your answer. All right, for question 4, to find CD, we can call this x. I should set up the equation x equals the square root of 25 times 36. That's both parts of the hypotenuse. So I multiply 25 times 36 and take the square root. You should get 30. Now, to find BC, BC we can call y. So I do the part that's attached, 25, times the whole hypotenuse, which is 25 plus 36, and that's 61. So now I'm doing the square root of 25 times 61. You should get about 39. All right, for question 5, to find x, which was our missing piece down here, I can set up the equation 3 equals the square root of 2 times x. I square both sides, so 9 equals 2x, and x should be about 4.5. Now, to find y. Y is going to be equal to the part that's attached times the whole hypotenuse, so 2 times 6.5. So y will be the square root of 13, which is approximately 3.6. And lastly, we need to find z. So z is going to be the square root of the part that's attached, 4.5, times the whole hypotenuse, 6.5. So z equals the square root of 4.5 times 6.5, which gives us a grand total of about 5.4. There you have it, folks. That's all you need to know about the geometric mean. Hopefully you have some idea what's going on here, and you can come to class tomorrow ready to ask questions. That's all for now.